We have a panel with our folks who've been working on VR and AR in space exploration, and I thought it'd be nice to have a conversation with them to kind of dig beneath some of the work that has been happening. So we've got a number of speakers who you've seen already, but why don't we start by actually inviting Joel Burdick to present. He had one additional project that he wanted to talk about, and Joel is a professor here at Caltech of robotics.
Yeah, I'm an old robot guy. And actually, I don't work on VR, but I do work on space robotics. And the reason I'm here today is actually I helped run a KISS workshop just ended recently. We're actually still writing up the final report. And actually, it was quite closely related to this workshop. So I thought I'd just throw out a few things that we learned in that workshop to help promote some of the ideas here. And so what we were looking at is actually using low latency telerobotics and telepresence for space exploration. And so obviously the virtual reality that you guys are talking about today is a big part of that, but we're also looking at actually having physical agents on the ground on the planets to actually interact with materials, et cetera, in addition to being able to have a remote presence there. Scott, if you could go to the next slide.
Sure.
So these are some of the motivations for things we looked at. So one of the things was that actually the time we planned this workshop, it was likely to have a mission to Mars. Of course, Trump just changed that for us. And in that mission, it might be that before you land a human on the Mars, you might actually have an orbiter first. And the reason an orbiter makes a lot of sense is because to actually drop something on the planet takes an enormous amount of fuel to get all those scientists on the ground and get them back up and safely back to Earth, whereas it takes a lot less fuel just to orbit them around there. You can keep the astronauts in a much more safe condition from radiation and thermal effects, and also you can host an enormous amount of computing power in an orbiter that you couldn't be able to put on the ground. So there's a long list of reasons why you might actually want to have astronauts orbiting Mars for some period of time before you actually place them on the ground. And so this then raises the issue of actually how do you do low latency telepresence so that those astronauts could do useful things in preparation for a future landing. Next slide, please. Another one we looked at, which was also canceled in the meantime, was actually looking at the asteroid capture and return mission, where again the idea is you might actually have a series of astronauts located right next to the asteroid after it's been captured to be able to do science, and it'd be better for them to do that science telerobotically rather than in sort of spacesuits. So if you go forward. So really what we wanted to do with this study, and there's a long list of words up there, I'll just tell you in simplistic words, was that actually try to find the sweet spot of low latency telerobotics. So we already have high latency telerobotics right now, that's how we operate on Mars, and we have astronauts on the ground. So the question is, where is kind of the sweet spot in the middle? And so where would it definitely have to have low latency telerobotics, or where could be an advantage? And what kind of technologies and resources do we need to bring to bear to make that a reality in the future? So go forward. I won't say much about the study. We had an international group of people from areas of robotics and space mission design, et cetera, even surgeons and 2 astronauts weighing in. Next slide. And so the thing that kind of jumped out of us relevant to the talk today was that actually the bottom line was all of the scientists always had in mind the idea of a field geologist. You saw earlier today what a field geologist can do, and so they always wanted to have the telepresence sort of somehow meet the threshold of an actual field geologist on the ground. And so without going into detail, we were pretty confident that technologies like robotics and haptics and VR is reaching the point where we can actually put that presence there, but obviously there's a cost to doing that. And so now the question would be, what would be the right architectures to support something like that? And what are the kind of go-to missions that really require such an approach? And last slide. And so I'll leave you with this. And so here's, with respect to today's talk, kind of the 4 areas that we found where telerobotics, meaning virtual reality, and you guys are also looking at virtual reality for all kinds of efficiency of the planning. This is really just limited to kind of the real-time interaction with sort of the surface from a nearby astronaut. So the first one is actually searching for biological activity, primarily from the planetary protection point of view. So something I work on are these recurring slope lineae on Mars, and there's a debate on whether there's water there, or these are just sand flows. Every month a paper's published arguing one way or another what they are. We'd love to actually be able to measure it, but the planetary protection people are really afraid of actually putting anything there, particularly humans, because if it is water, there could be contamination. So a telepresence, robotically and virtual reality, to be able to study these regions before a human goes in seems to be a pretty critical feature. The second one we realized was opportunistic science. What happens out in the field, right, is a geologist sees something they didn't anticipate, something you couldn't see from the orbiter, or some sort of transient effect, like a methane release or recurring slope linear coming down, or a rock slide, or some other kind of event. And so what you'd love to be able to do is to quick don your VR goggles and send your robot out there and actually to that event and try to capture it as quickly as possible. The other one, of course, is astronaut protection, and not only from radiation, but challenging terrain. And the last one actually echoes what Charlie showed before with all the 14 screens. We felt actually having a telepresence would allow actually an astronaut to command a whole group of vehicles simultaneously and kind of keep track of them, so you could actually cover a much larger geographic domain using kind of current day technologies. So I just wanted to throw that out there. We're working on the final report from this study, and it'll be out hopefully sometime soon, or Michelle's going to kill me. So if any of you want that, just ask Michelle for a copy, and we'd be happy to send you a copy.
Thanks, Joe. Yeah, nice. Well, this is a good background for maybe making a transition to the conversation with the broader group, because I feel like what you really left us here with is opportunities for continuing work in this area. So let me just start by maybe asking the panelists, or the other panelists, to really talk about what are the applications that they see, both based on their experience and the ones that they're imagining doing in the future, are the areas that you see focusing on the tasks of space exploration that have the most potential for AR or VR, and why? So maybe I'll ask to Parker first.
Sure. Well, the task that comes first to my mind, growing out of my own work on on-site, is that one of the strengths of the immersive visualization is to give someone situational awareness of an environment they can't actually visit. So on-site in Mars is kind of the extreme end of that, where you can't get there, no matter how hard you try. But I think a lot of both space missions and science on Earth have similar challenges in that it may not be quite as hard to go to as Mars, but it is, it's not easy, and it's not easy to send a lot of people there. So some of the areas that we're interested in looking at is reconstruction and virtual presence in underwater environments, in ice tubes through glaciers, in lava tubes, in volcano calderas, on asteroids. And I think we see a lot of similar need there to put people virtually in an environment they can't actually be in. And I think there, as Joel was saying, there's kind of a continuum between low latency teleoperation like the Curiosity rover, where you command the vehicle quite a bit in advance, and more kind of immediate control. And there's benefit to telepresence in both cases. So you can imagine, remotely operating your rover or vehicle in real time as you're virtually standing next to it, watching it survey the environment, overlaid with information on the sensor feeds that the robot is sensing of its environment. And through that kind of human-machine collaboration, do more science with the vehicle you have. So that's kind of what comes to my mind as an active area of opportunity.
Let me extend the same question to Basak, because I feel like the applications that you're working on are in many ways different, in that Basak is trying to create an almost God's eye perspective as opposed to really a first-person perspective. I'm wondering, what are the additional benefits that you see going forward about VR for trajectory design, or maybe other examples that you think you've identified given the work that you've seen?
Yeah, especially the God's eye view is kind of the scale that is not unimaginable for the human, right? But the same goes for putting a scientist inside of a cell, or putting an engineer inside of a jet engine. Again, it's an unimaginable scale for us, but we are changing the human scale, something that is not possible before. But again, I want to emphasize that we need to really think about how do we calibrate. Although these things are possible, we can shrink ourselves and we can enlarge ourselves to God's view, this, that. But when you start doing these context switches so quickly, it really messes up with your brain. So we really need to think about how to stick to one modality at a time, so we keep the context preserved. But in terms of applications to other areas, I think trajectory design is not different than any other engineering design. Like, it's not different than designing a building or designing a, car or designing a, part, whatever. And again, the same things we ran into, you don't kind of start from scratch in this VR environment. Okay, let me create something, cool here. It is more like you work on a design, you work on a concept, using your 2D things, and you bring it into this 3D VR worlds. Now you acquire more spatial understanding of the details, and then you maybe do a little bit of modifications. And I realize it is certainly not ideal, like put your goggle on, put it off, but I honestly, till we get those AR displays that Doug was describing, we have to do something in between still, We have to kind of find a, way to make this goggle thing work with the desktops.
So speaking about this idea of this ecosystem and tools, Charlie, I was wondering if maybe you could elaborate a little bit on this design task that you did in VR to design this space. Because in some ways, I think many of the speakers today have acknowledged a kind of edge to where the capabilities for immersion would be successful. And the story that you told was that you actually did the design in VR. So I'm wondering if you could tell us a little bit about the experience and some of the things that were easy, and then some of the challenges that were introduced by really doing all of the work in VR.
Well, the challenges was to be taken seriously for the first part, because unicorns were not so serious. And there is a social, if we do have some time after, I'd like to talk about avatar personalities. But yeah, to get to your question first, quite honestly, when we proposed the Earth Science Center, it's in Building 264, which is very heavily contested space by all the projects. And all the projects had to promote, it had to take a director's level signature in order to get that space, the floor plan. So there were basically three competing groups. The first group came in with no PowerPoint, just a blueprint. And they showed the blueprint of what their space was, and they sat there and verbally told them about. The second group scared me because they came in with PowerPoint. And they had blueprints. So they came in with PowerPoint, blueprints, and a story. And I was really afraid of that. So then it was my turn to come up and propose the space. And I broke a JPL rule because here I'm playing a game on company time. So I opened up my laptop, I plug in, and I went into Second Life. And I said, this is my avatar, let's walk through the front door. So we walked through the front door and we walked all the way around the facility. And then we had other avatars in there. And not only did we show them the floor plan of how it actually looked, but as you saw in that picture, it had the wall colors, it had the three-dimensional globe, it had people sitting in the chairs, and it had a unicorn. and all of a sudden, Charles Lachi said, build it. And the other two groups were like, so that was the challenge right there. It's where's the money? And right there, we got the money for it. And so that was the seriousness that we were able to prove on them.
Well, let's dig in a little bit on the unicorn problem. Because I actually feel like that's a realistic question that perhaps sometimes we punt on and we say, people will be used to these things.
Right.
And I actually feel like that's a tremendous oversimplification. And in developing these tools for use by serious people doing serious work, right, you really have this intense identity interaction when someone is asked to put a gaming device or a device that they perceive as presenting a particular view of them to the world, so their presentation of self, that's probably not consistent with their ideal self.
It's, in the virtual world, I have hair. I'm a lot skinnier in the virtual world.
Well, perhaps it's closer to the ideal self then.
Yeah, you know. So I had a colonel from the U.S. Air Force. We were demonstrating this to walk up to me, and he was just like, Mr. White, I am totally against this because a unicorn shouldn't be a unicorn. It should be a person, and you know, they should be wearing you know, proper business clothes. And some of this stuff about their personality, that's maybe too revealing about who they are. And I said, oh, Air Force, huh? You're a colonel. I know your pay grade. I see the medals you are wearing. Everything you are wearing tells me everything about you that are right there. But here's the thing. If Stephen Hawking was in a virtual world, are we going to make him sit in a wheelchair? Seriously? Something else that happened, that unicorn, when we asked the unicorn to wear a business suit, that unicorn was quiet. But when she was allowed to be a unicorn, she participated in the group meetings and she was activated. So who cares? You know, but that was one of the problems that George and I ran into with being adopted, because here's a unicorn, and all of a sudden we knew Corey Tiger was fine being a unicorn or a tiger, but all of a sudden it was like conform, and then she shut down. So we really didn't care about that. But when other people saw this unicorn or a tiger walking through, they used snap judgment on them right away. So these are social issues that we're going to have to address when we get into these virtual worlds. But no, I'm not going to be the guy to put Stephen Hawking in a wheelchair in a virtual space.
Parker, what was your experience in the particular representation of self that you chose for the scientists as part of on-site?
Yeah, that's a great question. So I didn't have time to discuss this in much detail in my talk, but OnSite has a multi-user capability, and it's actually one of our more popular features. Because one of the challenges of operating the Curiosity rover is that our science team is spread all over the country, and we're asking them to come to a common understanding of the surface of another planet when they're not even in the same room on this planet. So with OnSite, we can put people together virtually on Mars in the same place and let them have a conversation about the environment in that environment. So we ran into the same question of how do we represent people in this environment. And we talked about all the options, like should they be fully customizable avatars so everyone can be the shade of unicorn they want to be? Should they just be like floating spheres to not even go there? Should they be little Martian, like Marvin the Martian or something? What we decided was kind of pragmatically, too much flexibility was too much feature scope for that point in the project. On the other hand, making everyone floating spheres seemed too simplistic. So we tried to go for the middle ground where people were represented as these kind of androgynous golden avatar people, like you may have seen in my slides. And I think there are good things about that design, and there are not such good things. One benefit is that having a human scale avatar is really valuable. And actually our users will use that as a scale reference in the environment. Because one of the interesting things about the Martian surface is there aren't a lot of scale references in the environment. It's all just rocks. And rocks kind of look the same at all scales. So having a person standing in there gives you some idea of, okay, that's about one human size yardstick. And sometimes users will even ask each other to like go over to stand by the hill so they have a good idea of how big it is. So that's the benefit of having some constraints on that type of avatar. On the other hand, we do lose a lot of that personality. Even though we tried to make the avatars kind of androgynous, they kind of look like men, and sometimes people comment on that. It's not ideal. So maybe we'll revisit that decision in the future. But that's how we tried to kind of balance that decision space.
Well, let me ask you a question about a topic that has been discussed at various points throughout the day, and it's this question about the essence of representation of 3D space in VR as one of the potential value propositions, and a question of how to be able to then integrate the idea of abstract data or other types of key parts of doing scientific and engineering analyses into a virtual representation in a way that will ultimately be successful and allow scientists and engineers to do more things than they can do right now? And I'm asking that in particular because it seems as though we've chosen in the various tasks that are being represented in this session, actually picking representational virtual reality environments, and that was the core of the work that you chose. So do you see adding abstract data or replacing real with abstract data or fusing them? So just a general question for the panel.
So I'll start. We generally see a lot of benefits in terms of fusing abstract data with this highly spatial data. People generally need to judge some abstract thing in the context of something bigger. So I work with orbit determination people at JPL, and they generally kind of look at plots and they compare like different scenarios. And I was thinking to myself, this plot has no meaning by itself, you know, absolutely carries no meaning. It carries meaning only within a specific representation of the universe. And that universe is in the user's heads. So as people are looking at these two different plots, they are like, in this one, my universe is represented this way. And in this plot, my universe is modeled in a slightly different way. And this is an incredible information overload for the user. I mean, yes, they are very smart people. They can do this with a lot of training. But technology allows us not to do this and be able to do this faster. The other thing I wanted to touch upon is about your previous question. There is a lot of resistance about adoption. Sometimes we bring people to give demos, and within the crowd, there are at least a couple of people who refuses to put the goggles on. So I sometimes go and ask them why, you know, like they say, oh, I tried it before and it gave me headaches or something. And generally they are tainted with the, you know, previous experiences of these very, very clunky, low resolution, high latency displays. So they don't even want to try it again. Or some people literally have like, you know, feel claustrophobic when they put the glasses on. So once we get Doug's AR glasses, all this will be sold.
Thank you, Doug. We're waiting.
But until then, I don't know how to address that problem. Yeah, we get a lot of resistance too.
So I'll just say one thing here. So just to echo what Parker said before, we had rover drivers as part of our study, and they were just completely, or continually, the word's not complaining, let's just say bringing up the perception ability, the perceptual awareness, strategic awareness of where they were as a constant issue. But here's something actually the geologists brought up quite a bit. So what they love to have is, in addition to sort of view of the geology, if there are any spectroscopic measurements taken anywhere, they'd like to be able to call that up. If there's any thermal studies done on any of the material nearby, they'd like to be able to call that up. There's actually a surprising number of wind models of different planets, and so they'd like to be able to call up the wind models from that region of the planet. Are there typical lot of winds here, so I could use that to interpret the scouring of the rocks that I see? Is that from wind or something else? Or if they wanted to actually plan some mission, what was going to be the short-term forecast for the winds for the next couple days in that area? So there was lots of additional information that they would love to be able to load on top of just the pure visual scene. And the other thing which was quite important for them is not only just the visual appearance, but actually dimensionality correctness, because they wanted to be able to interpret all the geological data, and so knowing which things were near to each other and how far apart they were was important for their correct geological interpretation of the prior history of what's happening geologically in a given area.
I think in the resistance part, we're always going to see people were resistant when typewriters went away and word processors came out. And then we saw resistance when the drafting board went away and CAD/CAM systems came out. And then we saw resistance for people not liking self-driving cars. And I was kind of one of those because I do lessons learned at the laboratory on what goes wrong and what goes right. However, my wife bought a Prius that has a new cruise control with radar. And it actually puts on the brakes and stops in traffic and goes. And the car, I call it R2-D2, because it's like, no, I'm not going to Alderan R2, but it drives itself. And now I'm part of the resistance that I'm losing, and now I want everybody to drive self-driving cars because your car is a better driver than you.
I agree with you on that. For me, the issue is some of the VR demos make. Sorry, I agree with you on the self-driving. Well, not on the self-driving cars, really stopping at the right distance.
Yes.
Which is a very good feature. The issue with the motion sickness and so on is that it's really due to the deficiencies of the technology that we are making people motion sick, right?
Yeah.
And I mean, to make that even worse, right? We even know how to make people motion sick in real world. Disney World is a great example of that. There's a reason they have benches at the exit of every ride.
During Parker's demo in the audience, I literally had to close my eyes and look away.
And that's human. And we can't just ignore that.
Yeah.
What I'm trying to say is we can't just ignore that, right? I mean, word processors, we're not making anybody sick. That's fine. Self-driving cars, we're saving lives, not a problem. If we're making people sick, I'm not so much for it.
Agreed. We do have to fix the technology.
Thanks. I'll ask some questions, but it seems like there's some more from the audience, and I'm happy to open up the audience for questions as well. So just please raise your hand and we'll get a microphone over to you.
So my name is Jian Yan. I real life robot driver. So let me make some comments about and also questions about this virtual reality device for driving on Mars. As Joe mentioned, the telerobotics and telepresence use VR is a must, right? Because right now we're not on Mars, but we have rover on Mars, and we need to command that. So one of the things I think is lacking at this point is the VR, is perception, and the real world maybe have some difference. And in our case, I give you an example. If I want to shoot a laser on some feature, microscopic observation, 7 meters away, and I want that accurate to the point of millimeters. But the VR world, can that give me that accuracy? Maybe not, right? So for the telepresence, also you have a moving object, you have a robot on the surface, and how do you represent what the robot sees, right? Mm-hmm. And then another comment I have is their control robot. I think, Scott, you mentioned earlier, 60-off arm is very difficult to control as a human motion, right? But for driving, you can say, hey, I want to just drive that point. So that's a waypoint driving. It's very easy, right? As long as you have correct coordinate, you can give it to them. But we're not going to manipulate each wheel to align that to driving that point. So there are higher level command module you can use to do that, right? So, but I think the most challenging thing is how to get the real world into this virtual world with sort of a measurable difference, so the operator can understand that, right?
Yeah, well, thank you.
It's not that easy. Parker can talk to that, right?
Sure. In fact, let me actually generalize it for everybody, and I think kind of reflect this as a question of confidence and precision. Because if what we're really talking about is taking tools that exist in these virtual worlds and saying, if we're going to put $1 billion rover and we're going to command it where to go, that when Jiang is going to give it commands, he's going to want to know that what he's telling it to do is what it's going to do. And I actually feel like that is a very, very important challenge. So I think we could ask the panel about how they address the question of accuracy, and it's going to vary very much by the project that you're working on.
I definitely have some thoughts on this. So I think what Zheng is getting at is that the reconstruction of a virtual environment is really only as good as the data that you have for that reconstruction and the algorithms that you use to perform that reconstruction. And it's never going to be perfect. So I think characterizing that error and understanding it and surfacing it to the user in a way that's actionable is really key to enabling things that work given the fidelity of your data, or that don't work given the fidelity of your data. And I think it's also a question of precision. Jane brought up the question of millimeter scale accuracy of pointing a laser. And I would actually argue that maybe VR is not the environment you want to be performing that task in. I think going back to something that Scott said, you can control a robot arm with your hand, but as your hand gets further from your body, it's actually not that precise of a measurement. And I think there will always be some things that are best done by pulling up a 2D image and zooming way into it and finding the pixel that's the one that you want. So I think, just to summarize, I think it's a question of characterizing error and surfacing that uncertainty to the user so that they can make the decision of how accurate do I need this reconstruction to be, and then use VR for the things that you have that fidelity of data for, and that makes sense to use VR.
So I think there was a question in the middle. I'm sorry, Joe.
I was just going to add one thing to that. Certainly that was a big issue that came up in our study. I work on robotics. We do mapping. So I think mapping is, in essence, when they reconstruct the world, it's a form of mapping. But I think there needs to be some more complex mapping. The other one you can do to deal with that, as Parker said, is to not necessarily use VR during the detailed control of that operation, but to have kind of what we call a supervised autonomy. So the idea would be is from VR, you identify that thing, and then you actually identify the features you want to hit the laser of, and then you really have to have a sort of vision-guided servo control on the laser so that it can actually sort of scan around and find that visual feature that you told it to go look at. So there are techniques to handle that, but it takes work. And one of the things that we came up in our study was that there are many tools out there that can help the rover drivers. NASA necessarily hasn't invested in all of them and to prepare the rover drivers to be most efficient. And so one of the outcomes of our study was to really suggest to NASA that much more of the budget up front had to be put into the kind of environmental situational awareness and planning and operational tools than currently is done.
NSL and Mars 2020 are not designed for VR. They're bolted on after. So we started our research after. But we may get to a day when we propose a whole new mission that is calibrated exactly to a VR environment. Right now, we're just like Lego pieces, putting them together.
So we ran into this precision issue a lot in the trajectory design, because when you're in this God's view, the small tweak you do, it like translates into thousands of kilometers in reality, and it's unlikely your intention. So one of the things we came up with is maybe you select this control point, and if you really intend to do fine calibration, you bring up a numerical thing and you use the dial of your controller to move the scale up and down. Can be one way. Another way we considered was maybe I don't want to do any of this fine tuning in this environment. Maybe I just want to annotate, hey, fix this, fix this, fix this in my VR environment, and take it to my desktop environment where I can do the fine tunings.
So I'm being told by the powers that be that it's time to take a coffee break. So let's say apologize to the people who had yet to have questions. Please come forward and ask them of the panel afterwards. Let's hear a round of applause for the panel. Thank you, everybody.